up next, so I'll, I'll be done on time.
Yep, go ahead.
Okay, you can see the screen?
Yes, we can.
All right. Okay, well, thanks for having me on. I'm going to cover some of our thoughts on managing chiplet-based devices. Really, there's going to be a talk that covers kind of requirements and challenges and a possible path forward. So what I'll do is I will go over what makes a chiplet-based design, a couple of introductory slides, and what we see as a management requirements. And then Hemal will take over to talk about chiplet management architecture. If I'm looking to the left, my screen with the slides is to the left. So at any point, of course, if you have any questions, please put them in on the chat box on the session. Hemal, is there anything else you'd like to say about the outline?
No, looks good. Go ahead.
Okay. So, excuse me. Yeah. So I am a sub-project lead for a project called the Open Domain Specific Architecture. And essentially what this project aims to do is that there's going to be an expectation that because of the slowdown in Moore's law, there's going to be a proliferation of domain-specific architectures where workloads are going to shift from general-purpose CPUs to silicon targeting a specific class of workloads. This is a kind of nice slide on from a nice little picture from Ramesh Jani at Facebook, which kind of shows a whole range of workloads which are showing up in hyperscaler data centers. And really, these workloads require really rapid silicon turnaround time for you to develop silicon really quickly. And chiplets are one way to meet that need. So where you implement your product as a collection of die in one package rather than as a monolithic device. So the picture on the right is from IBM, where they reimagined the Power 9 as a collection of chiplets where each chiplet implements some modular portion of the design. So this specific group looks at saying, how do we build open interfaces? How do we build open interfaces into chiplets so that you can mix and match devices from multiple vendors? What that naturally means, and what's the sort of the most relevant part from a management perspective, is that chiplet-based products employ heterogeneous integration. And what that means in plain terms is you're going to have a device which will a product which integrates chiplets from multiple vendors, IP from multiple sources. The same product can be implemented in multiple packaging technologies. The chiplets will be on, and each of the chiplets may be even at multiple process nodes, right? And the advantage you get on all this is that basically you're going to reduce the manufacturing cost and while preserving performance for the most part. And really, a lot of the attention on chiplets is focused on the die-to-die interconnect and how you need like a physical and logical die-to-die interconnect between these chiplets. And that's essentially what we are covering in a whole sequence of talks in the ODSA. What we're kind of interested in this talk is how do you manage them? So one of the things we've developed in the ODSA is this idea of a reference architecture, which kind of says, okay, let's take a standard accelerator. Let's decompose an accelerator into some standard constituent parts, a network I/O, which will implement NIC functionality, a general purpose CPU core, which will implement sort of whatever you want to run in general purpose logic, domain specific accelerator logic that may actually be in the highest, most advanced process node, because that's where that's the workload that's being accelerated. And now finally, it turns out that somehow, because all of these things are in one package, you need to find a way to integrate their management. One of the options we're looking at is this idea of a management chiplet, who from a completely fourth vendor. Now this management chiplet now has to manage and operate the other three chiplets in the package. It's also possible there are options where each of these three devices is exposed directly to the to a higher level management controller. So there's a bunch of things you need to do depending on what kind of a chiplet-based product it is. You'll need some kind of a common framework. More importantly, there's things like power sequencing, device initialization, and interface calibration, interface bring up. There's a whole bunch of activities that need to be coordinated at the package level. Because if you'll notice, there's like four there's 4 interfaces. Now, each of these has to be brought up. All the other chiplets in the package need to know that the interfaces have been brought up. So, and really, they all communicate to the host physically through, let's say, the network I/O device. So somehow all of this information has to sort of make its way to the host as well, right? And one of the interesting things, I don't have a slide on this, is that we as a group have built a hardware board-based design, which serves as a software development platform for accelerators. And that software development platform, it really has these components. It has a Broadcom NIC. It has a CPU collection of CPU cores with a daughter card from NXP, and it has a management chiplet from Lattice. So one of the things we're kind of interested in, we can do with any ideas we come up with, is to actually implement them on the on this POC, on this accelerator POC. In fact, working on accelerator POC has kind of led us to a range of services which we think chiplets require. And really, these range of services really get put into three broad categories, right? One is sort of inventory management. The second is monitoring and telemetry, and the third is and the third is operations. How do you run the device? How do you operate? How do you update the device, etc. So in terms of power, it turns out that when you have all these multiple packages, multiple chiplets in one package, you need to sequence the way you power them up so that you don't overload your power distribution network. In terms of configuration management, depending on what your model is for the chiplet, what your software model is, you'll have to allocate memory addresses, interface names. Really, even sleep mode might be an interesting thing. Then in terms of monitoring and test, you've got your standard collection of things that you want to do at a device level, except that you've got multiple independent components reporting inside a package. So you want to figure out, how hot is the device? Are there any error events that any component has reported, etc. And there's, like I said, turned out to be an interesting amount of complexity around test as well, because you now have to coordinate tests across multiple devices, system level test. Device A has to send patterns to device B, and then you need to store the result of a PRBS inside device B. So you need to do some degree. So built-in self-test also requires coordination. Power consumption in built-in self-test is a big thing. And then firmware, there's a whole bunch of security stuff that we really came up in a panel that we discussed this morning that isn't on this slide. Really, when you come up, you kind of want to know that the device, that one chiplet wants to know that the chiplet on the far end of their die-to-die PHY is actually the chiplet it's supposed to be. There's other security aspects, like you want signed and attested firmware, secure firmware updates for the multiple components. Do all of these come through the management chiplet? Do they all come directly from the board level controller? These are interesting questions to be asked. So I've kind of zapped through, since we're rushed through a bit, since we're behind on time on this track. Himal, at this point, I'd like to hand it over to you, and you can tell me when to move the slides forward, unless there's something else you'd like to add on this slide as well.
Nope, let's go ahead. So thanks, Pappy. The use cases, as Pappy was talking about, we had in the morning the panel on device management, and these are, chiplet is also no different there. There are some common use cases around inventory, monitoring, control, and firmware management. And if you strictly look at it from the use case standpoint and how a management client will manage this, naturally you can look at Redfish, which is based on common standard, which is defined by DMTF. It leverages all modern web service based standard. It's been adopted by OCP. It has clear separation of what is the underneath protocol from the data model. From a protocol standpoint, it uses all HTTPS, SSL internet standards. Built into that is also discovery piece. The data model is fairly rich, REST and JSON based. Also, this allows you to do very programmatic kind of management client, as well as the APIs and software defined. It's publicly available, so it's easy for from the management standpoint. And going back to those use cases, if you look at Redfish over the years since it started in 16 onward has been publishing 3 to 4 schema releases every year, and it keep enhancing its model. And so schema published with the data model covers at this point a lot of use cases. And looking at the chiplet specific for this talk, naturally from the management interface or external management interface standpoint, Redfish makes sense. So that's it fits in well with those use cases. We talked about the baseline profile on devices. This is something that hardware management track can look into across a number of devices that are being specs are being defined in server projects as well as in other projects. So with that, Bapi, let's go to next slide. So this is very simple view of chiplet management architecture, and simplistically you can look at it is a chip which has one or more chiplets. You want to manage this in hierarchical fashion. And what I mean by this is you want to manage all of them as one single unit as well as individual entity. And that's where having a management chiplet may allow you to have interesting implementation of either everything is managed as a unit or having direct communication with chiplet or pass through management chiplet, which allows you to directly manage each chiplet separately from chip. And if you look from that model and within server where you have this chip, which has one or more chiplets, you can pretty much leverage Redfish standard for the external communication. And then through that, you can expose this whole hierarchy. And internally, a BMC can communicate with all these different components using PLDM communication, which can extend the Redfish device enablement, as well as PLDM today covers a number of capabilities that are useful to support the use cases we are talking about. Additionally, internally, PLDM communication can be done over multiple transport, and each of these transport can run over different medium. So this will allow you to have different design where the different physical medium, depending on its availability, you can still do this PLDM communication in the underlying medium agnostic way. So this is how overall the chiplet management architecture from high level fits into. And as I was talking about, we want to look at it from the baseline profile extension standpoint, how this device model fits into that. So Bapi, let's go to the next slide. This one we covered in the morning in the PMCA standards overview, but just to recap on PLDM, for the internal communication between each individual chiplet from a BMC or from BMC to a chip or from BMC to a management chiplet, PLDM is a very well suitable data model. It's a low level, but it has rich enough in terms of features and the data representation command. It supports request response kind of model. There are different types within PLDM, which allows you to do different functionality like BIOS configuration, SM BIOS transfer, monitoring and control, basically using sensor-based modeling, access to through data, ability to update firmware, Redfish device enablement, which allows you to extend the Redfish data model to be extended all the way to each individual component, and then generic NIC model. So in summary, if we look at all these requirements and the use cases between Redfish as the external facing and PLDM with the standard transport, it gives you pretty much an end-to-end kind of solution from a management client. You can manage all these devices and also represent their hierarchy. And let's go to the next slide where we are showing an example. So previously, as Bapi showed that reference architecture, so you can think about this internally. The entire chip can be represented by a device model. which includes a NIC, an accelerator, it may be onboard CPU, and there may be a device manager itself within that. And then within that, a specific chiplet we are picking up here where you can apply PLDM NIC model. So that covers your NIC specific inventory monitoring control, firmware update, Redfish data model. So this is an example how the previous architecture can be realized using PLDM within the platform and Redfish management model from the management client. So with that, let me hand it over to Bapi to wrap up this session.
Sure. Thanks, Emil. So if you want more, and if you'd like more information about the ODSA, we've got about 15 talks spread across 3 different components. We have a session in parallel from 1 to 5, another one on Thursday from 1 to 5 across these various topics. So in terms of what we'd like as a call to action, I think one of the interesting things, at least ideas for me that popped out, was that, in chiplets, we define a physical interface and a logical interface. I think there's room to also define a management interface to sort of say these are the management capabilities you expect of an open chiplet that you want to integrate, and that roughly that these are the capabilities we expect. Then Hemal, I don't know whether you'd like to cover the rest of the bullets in terms of how Redfish and PLDM are sort of map onto this.
I think I talked through it, but mainly as I was saying, that leveraging existing standard will help us here with standards-based management. And as Bobby mentioned, next step is to include this generic chiplet model into the chiplet spec. You can see all the links here. With that, I think we should open up the talk for any questions. We don't see any on the public forum. On the call, any questions or comments? I do have a actually question for you, Bapi. Is we talked about this chiplet model for management incorporation. In terms of next step, how do we proceed on that one? And in the morning we had the panel on the device management in general. You have some thoughts on that?
Yeah, it turns out there's some interest. There's at least 2 other companies I know of that are interested in this space, and maybe there's room for at least outlining to a first step. At least the way we've done it in the ODSA is to sort of put out the equivalent of a white paper to kind of say these are the problems that we see with the next level of detail, and circulate that in the community and say, hey, we need to gather. This is the problem to be solved. These are the options to solve it. And generally that tends to go off and be circulated amongst the people who might be interested. And that tends to sort of form the basis for a working group of some kind. So hopefully there's room for a working group between the ODSA and the hardware management task force in following up on this. And sort of come, I feel like there's definitely room for develop a chiplet management interface. And just to make a aggregation of chiplets from multiple vendors much easier.
Thanks. Okay, with that, I think we are almost at the end of our allocated time. Thanks, Bapi, for the session.